Hello everybody. My name is Sharon Pillar. I am a project manager at Citizens for Pennsylvania's Future, or Penn Future. Welcome to our webinar this afternoon. And the title of our webinar today is Permitting and Inspecting Small-Scale Solar Photovoltaic or PV Systems in Your Community. And today we are joined with a wonderful attorney from Cozen O'Connor, Sherry Shapiro, who will be talking today about the legal considerations for permitting solar in your community. And Evan Endress will be walking you through the permitting process that we've developed. So welcome. Just a few housekeeping issues to point out to you that everyone is on mute, so you will not be able to speak during the webinar, but we would encourage you to ask questions throughout the webinar, and to do that you just need to type in your question in the little box on the right, and we'll be able to see the question, and we'll try to answer those as we go through the process or through the webinar today. And then at the end of the webinar we'll have some more time for question and answer, so you're welcome to wait till that point if you're more comfortable. So we have a lot of people joining us. We're very excited about that, and we're going to get started. Great. So just to run through the agenda very quickly, we're going to do a little intro about solar and the growth of solar around the region and in the United States. We'll give you a little bit of background on the Sunshot project and rooftop solar challenge that we've been working on, a project through the Department of Energy. Then we'll talk about the need for appropriate permitting and inspection of solar systems, the legal underpinnings of the model permit that we developed with our team, and then Evan's going to walk you through the introduction to the model permit, how to use our model worksheets, and then a little bit about what appropriate fees for appropriate permitting fees would look like for many communities, and then talk to you about some of our other resources that we have to offer you. So one of the big questions that we always get is, does solar actually work in Pennsylvania? And the answer is yes, it works really, really well. And to demonstrate that, or to show you a little bit why we know that's the case, this slide shows you the solar resource across the United States. And this is an average amount of solar that we get in various different portions of the country. And you can see where Pittsburgh is. And we're in sort of that greenish light blue area. And if you look down at the very bottom of the slide, you can see that the red and orange, those are the places that are getting the very most sun and solar energy. And then you go on the other end of that spectrum, and those in the purple and light blue are the least amount of solar energy. Well, if you look over to the right, you'll see in purple here, Germany is oh, sorry, I can point it out here with our cursor. Germany is right here. Germany, as you can see, is this purplish blue color because it really doesn't receive all that much solar energy, but it is the leading solar nation. They have more solar installed than any other nation around the world. So we compare that. That's a lot very similar looking to Alaska, which in some cases is a little bit better off as far as the amount of solar they're receiving. So you can see that here in Pittsburgh we receive a lot more solar energy than Germany, and we have a great potential here for solar energy to work. So what's going on in Pennsylvania? We have, first of all, solar is the fastest growing energy sector in the entire world, and we're seeing a very rapid expansion of solar across the country and even here in Pennsylvania. So we have about 170 megawatts of solar installed in Pennsylvania, and that's enough to power about 18,000 homes. And we actually are a leading solar state. We are ranked 8th in the nation in the amount of total solar capacity, and we have about 7,000 solar systems. Most of that has come onto the grid just within the past 4 years. So you can see how rapidly this is expanding. And Pennsylvania has the 4th fastest growth rate in the United States, and we're employing thousands of solar jobs in Pennsylvania. So we're here to talk to you about a project that we've done with the Department of Energy called Sunshot, and we've been working on the Sunshot Rooftop Solar Challenge. So the Department of Energy has various different Sunshot initiatives, and the whole purpose of this is really kind of summed up in the logo there at the bottom, that $1 per watt is really the goal that the Department of Energy is shooting for, where solar energy is cost competitive with fossil fuels, and that is happening at an amazing and very rapid rate. The other objective with the Sunshot initiatives is to help increase the U.S. competitiveness in the global solar industry, because around the world solar is being manufactured and deployed, again, at a very, very rapid rate. So we need to keep pace with that as far as our country is concerned. And then the other piece or objective is to reduce the non-hardware costs of solar energy projects, which is a key element to bring down the cost of installed solar energy systems. And the non-hardware costs, or what we call soft costs, are those that we're going to be talking about today. And so we participated in the Rooftop Solar Challenge. The Department of Energy found that there was inappropriate zoning, permitting, and inspection procedures, that these were a significant burden of installing solar energy. They've been adding excessive costs to customers, and sometimes we're talking about thousands of extra dollars to these installations for what we would call inappropriate permitting fees. Sometimes sending folks to their zoning hearing boards to get variances where it's probably very unnecessary, or at additional municipal hearings. Also delaying the installation of the solar systems through lag time on inspection and interconnection by the utility costs. So the longer it takes folks to get the solar systems up and running, that is a cost to the solar industry, but also a cost to the customer as well. And also requiring the industry to navigate a wide range of inconsistent policies across jurisdictions. And you can just imagine in Pennsylvania, where we have more than 2,500 municipalities, how difficult that is to navigate each and every municipality. Most of the Pennsylvania municipalities don't have any established guidelines or regulations for zoning, permitting, or inspection procedures for solar. So either the communities are under-regulating and not really sure what to do with the solar systems, or either they're over-regulating and asking for burdensome and really sometimes unnecessary requirements, which adds a lot of cost to the municipality's review time as well. So we have done this as a part of a coalition with our organization, and Penn Future is a statewide organization that is involved in, we're a public interest organization working on environmental issues like air quality, water quality, and clean energy has been a very important piece of our work. We also partnered with the City of Pittsburgh, Allegheny County, Southwestern Pennsylvania Commission. Connect, or the Congress of Neighboring Communities, is an organization out of the University of Pittsburgh that works with the municipalities around the City of Pittsburgh. And SunWIPA, which is the Solar Unified Network of Western Pennsylvania, and that comprises the solar industry here in Western Pennsylvania. And then we were lucky enough to be working with the experts with our environmental planning and design, who helped us largely with the zoning portion of the project, as well as some of the permitting processes, and attorneys from Gehring, Rutter, and Beam in Pittsburgh, and Sherry Shapiro, who's with us today from Cozen O'Connor in Philadelphia. Bill Brooks, who some of you may know, is a national solar inspection expert, and we also had the Clean Energy Finance Center working on some financing components of this grant to try to find some financing mechanisms for solar in this region. We were one of 22 teams. Really, we were the only one in Pennsylvania, and you could see these orange dots This large orange dot here really is New York City and didn't really encompass Pennsylvania. So we were the only team in Pennsylvania. And throughout this past year we've been working on this project. We have completed the model zoning ordinance, which are not talking about today, but which is available, and the model permitting practices, which of course we're talking about today. But to get to this point, we have gone through an extensive stakeholder consensus building process where we have started out with researching various models around the country, interviewing all sorts of knowledgeable people in this region. And then throughout the year we had 4 separate meetings with representatives from all the 24 municipalities who were involved in this project in Allegheny County and Beaver County through municipal working group meetings. We also had a technical advisory committee. That committee was kind of what we tried to do is comprise a mini microcosm, a separate municipality. So we had borough managers and engineers and zoning officials on that, and elected officials, as well as county planning officials, the solar industry, and various other folks who were helping us with their technical advice. We held elected official briefings, and we also held an electrical inspector training that was completed with Bill Brooks, who I mentioned before is a national expert, and also the International Association of Electrical Inspectors was part of that training as well. And then again, review by the attorneys who are knowledgeable in the Pennsylvania Municipal Planning Code and the Uniform Construction Code here in Pennsylvania. So why do we need solar permitting process? This picture is a great example of why. This picture shows what one installer was required to produce to get the permitting process for just one small installation. And this enormous amount of paperwork just for this one installation just exemplifies one of the reasons that there's a need for a streamlined process, not only from the industry side, but also on the municipal side, because you as a municipality need to, it's helpful to understand what's actually needed and what is not needed in order to save you time and expedite the review process. So before we get into the nuts and bolts of this, we just wanted to show you some results of a study that was done in the National Solar Permitting Database, and this was a survey of 273 solar installers in the top 12 solar states, and that does include Pennsylvania. But what they found is that more than 1 in 3 installers avoid selling solar into about 4 different municipalities because of their permitting difficulties. So the installers will say, I'm just not working in that municipality because it's just too difficult, it's not worth my time. So that is happening. Permitting varies widely and usually involves up to 5 distinct agencies within these municipalities. And of course some of these municipalities that they're talking about here are some of the larger municipalities. But again, it's requiring different reviews by various different people. About 11% of the installations encounter a situation where requirements for solar permitting have not been set, suggesting that the local policies have not kept pace with the burgeoning solar market. So again, solar is growing so quickly, it's just difficult for a lot of municipalities to keep up for the necessary requirements. The jurisdictions are requiring on average nearly 8 work weeks to complete their review. And of course the staff time for the installers to prepare the documents has been about a little bit over 14 hours. Municipalities report that installer errors and incomplete or inconsistent paperwork create extra work and delays for their staff. So the permitting process that we've developed today should address this issue, because it's asking each solar installer to submit the correct and appropriate information each and every time they're submitting an installation. So that should be prepared accurately, and that should save the municipality time. And then they also found if a municipality understands solar and wants to work with installers, there's currently no channel by which they can communicate to the installers about updates or process improvements. And this would be very helpful to have an online permitting process, which we are looking at addressing in the Rooftop Solar Challenge 2, which we're applying for a second phase to this work for an application with the Department of Energy, which Evan's going to talk to you about when we're done. So with that background, we are going to move into the legal considerations that Sherry Shapiro is going to set out for you. And I'm going to turn it over to Sherry at this point. So thank you so much. And thank you, Sherry.
Can you hear me?
Sherry, I think, yes, we can hear you.
Terrific. In a minute, can you see my slides?
Yes, we are up and running.
Fantastic. So thank you, Sharon. 30 seconds on my background. I am an attorney with Cozen O'Connor, and I specialize my practice in green building and renewable energy. I have a particular specialty in codes and building permitting and so forth.
Welcome to GoToWebinar, Web Events Made Easy.
Process from the building permit side. And I was thrilled to have that opportunity. Now, I want to make a disclaimer before we start, because lawyers always like to make disclaimers, which is this is a model process, and law is always changing. What the requirements are for individual municipalities are very specific to those municipalities. So although this process is a model process, each municipality has to have the process reviewed by their solicitor to ensure that it confirms and complies with all of the requirements and regulations that apply to that municipality. With that disclaimer, and the one provided on the next slide, we'll go into a little bit of background on the regulatory environment in Pennsylvania. For the code officials and some municipal officials, this will be very, very familiar. At the state level, we have the Uniform Construction Code, which requires all of the municipalities that opt in to enforce it that their construction within their municipality comply with the requirements of the UCC, which in turn requires that the construction comply with the International Code Council's suite of building and mechanical and so forth codes, the 2009 edition. While that is required at a state level, the administration is generally done at the municipal level. There are two kinds of municipalities. There are opt-in municipalities and opt-out municipalities. Opt-in municipalities enforce the UCC through their municipal code officials or third-party inspectors, and opt-out municipalities, the UCC requirements are fulfilled by the Department of Labor and Industry at the state level. So that's the background, and this creates a sort of complicated legal structure because there are the state-wide requirements, and then there are the municipal-specific requirements that are related to either the administration of the UCC or its enforcement. What we tried to do is to address these state and local issues and to model the permitting process after the city of San Jose that has a very efficient, practiced permitting model, and also after the city of Philadelphia's, which has had an expedited permitting process for small-scale solar for some time. With all of that said, they are modeled on these, but not a precise duplicate because of some considerations for other municipalities and to try and make it a procedure that has some flexibility. This is limited to small-scale PV systems, up to 13.44 kilowatts. And this is very important because obviously you want to make sure that when you add the solar system, it won't have a dangerous effect on the structure that it's being installed on. So we wanted to make sure that to the extent that there's going to be an expedited process or expedited submission of materials, that they weren't a threat to health and safety. So the permit form, let's start with there are two pieces to this. There's a form and a process. The form itself combines a building permit and an electrical permit into one combined permit. There is no legal requirement that they be separate, and so they can be combined into one application. And this simplifies matters, avoids duplication of submissions, duplication of information, errors that might arise with different applications, and so forth. There is generally no engineering study required with this application. There is required significant information on the weight of the system, the structure of the roof, the structure of the racking and installation for the system, but the plans are not generally stamped by an engineer. And the reason for this is that these systems are very small and are akin to other systems that don't require stamped engineering plans, don't generally require stamped engineering plans, like HVAC systems and roof replacement and so forth. There is a caveat here, which is there's an ambiguous area of law as to whether code officials can waive the requirement of engineered construction documents on commercial facilities. There is no ambiguity in the law for residential, for residences. There is no requirement under the UCC for stamped plans for residential construction. So many municipalities have processes and permitting processes for small-scale equipment, and in Philadelphia for solar installations that do not require stamped plans for either commercial or residential construction. So the key thing to look at here is to the extent that this permitting process is going to be used for both small-scale residential and commercial applications, which we designed it to do and hope it will be used for that. Your solicitor should look at whether stamped plans are required. There is an exemption under the Uniform Commercial Code, but we wanted to point out that there is some ambiguity there. And another piece to this is the electrical inspection after installation. The small-scale systems do not have a large structural impact. And so the concept behind the process is to have an electrical inspection, but not both an electrical inspection and a structural inspection. The thing that I want to say about both the engineering study and the inspections is that those are subject to the judgment of the code official with respect to the health and safety of the individual project. And what, as that documentation slide showed, these systems, the code officials and the municipalities have required an enormous amount of documentation because of the perceived risk of these small-scale systems. And what expedited permitting processes in many other places, including San Jose, Vermont doesn't have any kind of inspection requirement at all, is that these systems are extremely small and do not have a health and safety concern when properly installed. In continuation of that concept, from a health and safety perspective, we have to be sure that these small-scale systems do not have structural implications, do not overload the roof, and so forth. And in order to do that, the permitting application process that we have developed provides for standardized technical documentation that has the electrical diagrams, the spec sheets, the information about the roof, and the loading calculations, and so forth. And so these are designed to make the submission of technical documentation very standardized to both expedite the process and, more importantly, to give code officials the security of knowing that there is technical documentation supporting the installation, and that and to verify that these really are small-scale systems appropriately installed on the rooftops. The other thing that we did is we recognized that there's concern over over solar being improperly installed or improperly approved. And so what this permitting process did was first to set experience and certification requirements for the installer. There's a lot of fear that solar is a gold rush, and every contractor is going to jump on board and hold himself out to be a solar installer. And one of the things that the permitting process does is to require certifications for the solar installer that Evan is going to describe in greater detail. The other is to have a certification by the solar installer accepting responsibility for the roof structure and the PV system. Under the law, they are already responsible, but this makes it very explicit that they have a responsibility and absolve liability to the municipality for, or the inspector for issues of roof structure and installation of the PV system. Let's talk a little bit about liability, which is a question that we've received from a lot of code officials and municipalities. What if I approve this a solar installation by this expedited permitting process, and the solar installation falls off the roof? Am I liable for? Is the municipality liable? Are the individual code inspectors liable for this damage? And for municipal code officials, the law is very clear. municipalities and other local entities are immune from tort liability, and absent crime, actual fraud, actual malice, or willful misconduct, the immunity extends to government employees as well, which means that if you're following the permitting process that the municipality has approved in reviewing the plans and approving the solar system, then you will not be individually liable, and the municipality will not be liable. For third-party inspectors, there was no explicit ruling or decision on this until late October of 2012. And there was an unreported decision. And an unreported decision means that a judge makes a decision, but it can't be used for any later cases. It's just a decision for that particular case. And in that case, a third-party inspector improperly inspected a foundation and said that it complied with the UCC when it did not. And the court did not say whether or not the third-party inspector was actually liable, but did set a standard for third-party inspector liability. The court made it akin to the professional negligence, as with an engineer or an architect, and that the fact that third-party inspectors have to carry insurance against errors and omissions made the liability associated with third-party inspectors subject to the professional negligence standard. Now, this is not a particular concern in this case because the professional negligence standard in Pennsylvania is one where the code inspector or whatever professional's conduct will be compared to the reasonable conduct of similarly trained professionals in his or her field. And one of the ways to demonstrate this is that you were following the law and the permitting requirements of the municipality. So if you were not following the UCC or the requirements of the permitting process, then it might be negligence. But if you are performing your obligations in a reasonable manner and using the permitting process that the municipality adopts, then this liability is not a concern. In addition, if there is an error or an omission and you are found to be negligent, it should be covered by the errors and omissions policy that all third-party inspectors are required to carry by law. So that's the basic legal framework under which the permitting process and the permit has been developed, and I am available for any questions now or in the future.
Okay, Sherry, thank you very much for that legal overview. Obviously really important to what we're about to discuss in a moment. And let me just make sure that everyone's muted here. Great. Okay. So now we're going to go into the model permit itself. So this is a different way of doing sort of a presentation, but because we're dealing with a lot of pieces of paper, this was more appropriate. So bear with me here. I don't have as much experience with this format as I do with some others, but here's our permit process that we came up with. It's a simple 1, 2, 3 pages, and it covers quite a bit, but in a very concise way, consistent with the industry standards that have emerged out of the solar industry recently. So I just want to. Some of this is going to be a little bit of review from Sherry's, but the main underpinnings for the model permit were so. First of all, we based it on an emerging national best practice for permitting small-scale solar installations, and this best practice was developed by the Solar American Board of Codes and Standards, the Solar ABCs, as they're called. And this board is a collection of professional organizations and professionals such as Underwriters Laboratory, the National Electric Code representatives are there, and they construct pieces of model practices for the solar industry. So they formulate standards. But we also based it off of a similar combined building and electrical permit that are used by the city of Philadelphia, right here in Pennsylvania, and the city of San Jose, California, which the city of San Jose has been at the epicenter of the solar industry for quite some time, more so than Pennsylvania. They process thousands of solar installation permits every year. So the model permit that we came up with is designed to apply to the majority of PV system types and sizes that you are likely to see. And the majority of PV system installations are smaller installations, especially the ones that are going to come across your permit counter. In our model permit, we recognize the pre-engineered and modular nature of today's solar installation components. And I'll refer to this anecdotally a few times through the presentation, but go back 10 or 15 years, and what you find is, I'm sorry, 1 second here. What you find is a lot of, when the industry was young, things such as racking systems were maybe being welded together in someone's garage, or someone was improvising a component because it wasn't commercially available. That is not the case in today's solar industry. Solar components are readily available, pre-engineered, out-of-the-box systems. They come often they're certified for use in solar installations. They come with spec sheets. So this is an important thing to understand, that it is not the wild, wild west out there. There's industry standards and equipment standards as well. Our model permit provides for a rapid assessment procedure to determine weight impact for small-scale systems, which small-scale systems typically weigh less than 5 pounds per square foot, which is less than a second layer of shingles, which putting a second layer of shingles on a roof in Pennsylvania often does not require a permit, depending on the jurisdiction you're in. So these are some of the important underpinnings in which we design this process. And I'm going to go into greater detail on some of these. You may be asking, okay, well, where are these numbers coming from? What about what kind of sheets? And I'll go through that. Like I said, I'm getting used to this type of presentation model. So what about our model documents here? Well, first and foremost, we have a section that that outlines some applicability. Now, there are some basic requirements that we have outlined based on PA state law, based on size restrictions, based on the National Electric Code that would if the system doesn't meet these requirements, then you would need other to go into some other system. Maybe your municipality could use this as the basis for the system, but you would have to determine some other inspection points if this system does not meet these minimum requirements. So the first one is total inverter capacity of 13,440 watts, so 13.44 kilowatts or less. Now that sounds like an arbitrary number, but it's not. It's actually based on something very practical, and a very practical electrical consideration, and I'll show you that right now. So when you get into a system that's above 13.44 kilowatts, you're looking at an inverter size that is a size that is rated above 70 amps, okay? And when you upgrade to needing an inverter that can handle above 70 amps, then you also need to upgrade may need to upgrade some of the existing home infrastructure. So in this case, the breaker panel. In that case, this permit process does not apply to those extra steps that you would need to take with your electrical inspector. So that is a very practical reason why 13.44 kilowatts is the ceiling. And of course, here you can see in this diagram some of the other components that are involved in a solar installation, but primarily that 13.4 has to do with the amperage rating on the breaker and your existing AC breaker panel. Anything below that, and it shouldn't be a concern. The AC breaker panel would be able to handle in that case. So we also provided some. I'm sorry. So 13.44 is the system size. A distributed weight load of less than 5 pounds per square foot, and I'll tell you how we get there by using these sheets a little bit later. A point load, I'm sorry, so that was distributed weight load of 5 pounds per square foot, a point load of less than 45 pounds per square foot. And once again, there's a way to assess this weight load in a rapid manner. Installation on a roof with a single layer of lightweight roofing material. So we talked about that second layer of shingles. If a roof already has a second layer of shingles, then you might want to look at some other issues, weight issues with the roof in addition to the solar panel. A mounting structure with an engineered product designed to mount PV modules with no more than an 18-inch gap beneath those module frames. This is a fair, like I said before, the mounting structure that an installer is going to use these days is 99.9% of the time going to be a pre-engineered system. It's an industry standard. So then the installation is overseen by a trained solar professional and a licensed Pennsylvania contractor. Finally, the installer assumes liability for the installation and the roof structure as it pertains to the installation. Now, Sherry covered this before. Installers are already liable, but we provide some places in this permit document where they're attesting to that, and it serves as both a check for the counter and for the installer. So then there's some places in here for some information, questions to be directed to the installer, some places for the address of the project and the applicant. Going back up. Okay. Then we get into the installer certification. So what is their certification? We're dictating that they need to be certified in one of 4 areas. The first and foremost is NABCEP certification. So this is the National Association of Board Certified Energy Practitioners. And this is the gold standard in solar installation certification. But we also accept UL certified solar equipment installers, so that's a accredited installation certification. Electrical contractor with a license accepted by the municipality. So an electrical contractor is oftentimes qualified to do this work. And then finally, a solar installer on the approved list of PA Sunshine of the Pennsylvania Sunshine Grant Program. So that merits some explaining. Pennsylvania has a grant program that reimburses a certain amount of the installation, and this program's been going on for about 4 years. They did have a list of approved, and still do have a list of approved installers, and they put those installers through a vetting process. They inspected their first few installations. They are subject to random inspection of installations, and they did have to attest to a certain number of on-site hours before they could be in that qualification. So name the person with the above qualifications. Then we get into the structural review of the mounting system, and we'll go over that in a little bit more detail. But this is a very easy operation, a very plug-and-chug operation, and we'll reference where these numbers are coming from for these yes/no answers. Then finally, we're getting into the electrical review. So there is a lot of electrical items that need to be covered with a solar installation. So once again, there's a very easy way to get to these answers, and we'll show that. And then finally, the inspection of the system. In our process, the inspection is done by an electrical inspector. Now, this last section here is, once again, the sort of testimony of the solar installer as outlined by Sherry earlier. So we do provide that, that framework in our model permit. So we're going to dive a little bit deeper now into this. Let me get there. So we're going down the roller coaster here. Sorry, bear with me. There we are. Okay, so this is a slide from before. As you recall, this was a single permit process for a single installation. A lot of man hours, both for the permit counter at the municipality and for the installer himself or herself. But a lot of information here, a lot of information that could be assessed in more practical ways. So let's compare that then to everything that's required for our process. And here it is. So these documents, this collection of documents, as you're seeing now, is what would be required for the permitting process as outlined in our model. And I'll go through these real quick, what we're talking about here. And this is actually a completed sort of mock permit. We worked with one of the installers from our area here to put in some information as it would be, as he would use this in the field. So we have a real practical example here for you. So first is the application as completed, 3 pages, filled out by the installer. And as you see, it is filled out. We'll get a little bit more detail on that. And then with the application comes, we're asking for a spec sheet. So this is a spec sheet for the module, the solar panel itself. And there's some really critical information on these spec sheets. But these do come with the installation. Then spec sheets for the racking system. It's a important component of the solar installation. It has a lot of, once again, a lot of vital information is here. There's a lot of engineering specs and a lot of information that can be used to assess the impact of this installation on a roof structure. Let me see here. Sorry, once again, we're on a roller coaster ride here. So let's do this the old-fashioned way, I guess. Okay. Then we're asking them to submit installation manuals. Okay, so the Unirack system, for instance, comes with an installation manual. That's something that the installer can submit for the benefit of the municipality. Then we have spec sheets on some of the electrical components, inverter, and the solar modules. So these are a bit of a spec sheet of a different nature, but they're an electrical spec sheet. And then we have some diagrams that we're asking the installer to submit. One of these diagrams is a site plan, and we actually provide a model document for submitting a site plan, but you can see underneath that there's a site plan that the installer that we worked with submitted. So it's a very simple document that shows the general layout of where things are in relation to the property. So this is the roof, and then the panels are here. And then a electrical diagram. This is going to be important for the electrical inspection component of the installation. Now, if you notice here, there's a lot of information to fill out, about the different components of the solar installation. But once again, all that data is available on the spec sheets. And then, so this diagram, this electrical diagram, is a two-page guide, a two-page format, and there is a lot of electrical data, and this is what your electrical inspector is going to pick up and use for the electrical inspection at the end. And I'll get into that a little bit more. So let's look at the permit and where the installer got some of this information from. So here's the first page, and once again, the installer has filled out, as per the instructions, some basic information: name, at the application fee, some basic contact information for the location of the installation, and for the customer if necessary, but establishing a single contact, obviously. Then moving on to the second page, what's this installer's certification? In this case, this installer has both NABCEP certified, and he is on the solar installer, approved solar installer list for the PA Sunshine program. So he's on both of those. He clicked both of those, and then there's the installer's name once again. Then we're getting into some of the step one, which is the structural review of the PV system, and these are some specific questions about the mounting system. And this is a yes/no proposition. If the answer is yes to these, then you can use this as it is to assess the solar installation. But if there's answers no to any of these, then your municipality need to work with the installer to answer the additional questions that need to be answered. So once again, this information can be used as a base for that approach. But if no to any of these questions, then that should throw up some signs that you need to work a little bit closer with this installer to vet the installation and the structure that it's on. So does the roof have a single roof covering? Yes or no? And that's easy to determine. The installer can go ahead and look at the roof shingles. Is the roofing type lightweight composition or of a lightweight roofing material? So composition, lightweight masonry, metal, etc. In this case, the installation was composition, so a standard sort of tar shingle roof. Is the weatherproofing sealant compliant or compatible with the roofing material? Describe the method and type of weatherproofing of the roof penetrations, flash or caulking. This installer noted that the flashing was provided with the Unirack mounting racking system. So they already had a prescribed method for flashing the penetrations. Has the installer conducted a visual inspection of the roof and confirmed that there is no pre-existing damage? If damage is noted, provide details for any work necessary to repair the existing roof structure. So there's an opportunity for him to add an addendum if he's noting any damage that would impact the installations. Once again, yes or no to any of these. So now mounting system. This is where we're getting into some of the concerns about weight. So first yes/no proposition. Is the mounting structure an engineered product designed to mount PV modules with no more than an 18-inch gap beneath the module frames? And the answer was yes to this. And so he was asked to complete some more information. So mounting system manufacturer. It's called Unirack. It's once again a pre-engineered out-of-the-box mounting system. And product name and model number. It's called Unirack Solar Mount. And there's the model number. Total weight of PV modules and rails. Well, how does the installer know this? Once again, we're going back to those spec sheets that were asked for. So the installer actually went through the spec sheets. First he started with the module specification sheet. And there's the weight right there. 46.7 pounds per module. Okay. Then he went to the racking spec sheets. All right. And that data is located in a few different places, but it's readily available. So right here, there's some weight involved in the L-foot bracket, some weight involved in the beams. So there's a per linear foot for beam and a weight associated with that. And then let's see. So an end clamp weight and a mid clamp weight. So all those combined gave the full installation weight. And he was able to determine what that combined weight would be. So the total weight of PV modules and rails from the spec sheets is 1,550 pounds. Then he's being asked what are the total number of attachment points, right? So the racking system, how many beams are coming out of the roof structure for the attachment system? And in this case, there were 52. So what he's asked to do there is take the total weight of the modules and rails from line B, right here, divide it by the total number of attachment points from line C here, and he gets 30 pounds. And then is asked the question, is the point load weight in line D above less than or equal to 45 pounds? And it is less than 45 pounds. It's 30 pounds, in fact. So if yes, complete the following. So now we're going to be asking him for the distributed weight. So once again, he's taking the specs on the installation. Maximum spacing between attachment points is 48 inches. Total surface area of the PV modules, once again, he's getting that from the specification sheet as I showed you, 558 square feet. And then he's being asked to determine the distributed weight of the PV modules. So total weight of PV modules from line B above, once again, that's the 1,550 pounds, divided by the total surface area of the PV modules from line F, that's 558 square feet, is 2.77 pounds. So the distributed weight is 2.77 pounds, and that is less than 5 pounds per square foot. And I should note that that is far less than the 35-pound snow load that distributed snow load that roofs are spec to today. So the conclusion here, and once again, this was designed, this was built off of a real installation, is that the weight impact is fairly insignificant compared to especially compared to a second layer of roof shingles, and compared to the snow load, which is the 35 pounds per square foot. So we're coming in far under the tolerances that a roof for today is designed for under these conditions. Then we go on to step 2, which is the electrical review. And so we have some very practical questions to answer about the electrical portion of the PV system. Once again, we're asked that total inverter capacity, because if it's above that, then there's some amperage and breaker issues that need to be worked out then with the electrical inspector and the installer, and maybe some upgrades in the home. PV modules, utility, interactive meters, and combiner boxes are identified for use in PV systems. So once again, he's supplied all the spec sheets, so it should be very clear to the electrical inspector that these are for solar installations, that all these components are for a solar installation. The PV array is composed of 4 series strings or less per inverter. That's a practical consideration for the electrical part of a solar installation. The AC connection points is based on the load side of the service disconnecting means. Once again, very practical. This is all for electrical inspector to be understanding with the solar installer. And then finally, can one of the 4 standard electrical diagrams be used to accurately represent the PV system? And then once again, those electrical diagrams we provide in the guidebook, and the example is here. So this is one of the 4, and this is actually the most common electrical diagram. So this format is for the installer to fill out, answer all the questions. This way, the electrical inspector can look at this document before he even goes to install or to inspect the solar installation, and he can see what he and determine what he's supposed to see. What expectations does this set? And standardizing this process means that hopefully an electrical inspector will see this same document applied to multiple installations, and be ready to interpret and ask questions based on these documents. So this is a really important portion of the permit. And once again, these questions are being answered off of the pre-engineered spec sheets. The tolerances, the load tolerances are all pre-tested on these items. And once again, this is not the wild, wild west. These questions are the answers to these questions are readily available. So we've taken an approach on this that provides all the relevant information for the for the counter, for the municipality, but really eliminates this kind of trend that we're seeing here. So we certainly hope that you will use the model permit as a basis for discussion with your inspectors and discussion with your counter folks about the merits of this approach for certain system sizes. And once again, this gives us an opportunity to see what's all involved here. So let me just take a break or take a second and look at a couple questions from the audience. And bear with me. Okay, so I have a question here about microinverters. So yes, microinverters are a technology that we see deployed in solar these days. So that would take, if you look at this diagram, this inverter box, what the inverter is used for is to convert direct current, which is what solar panels produce, into alternating current, which is what our appliances and our grid uses. Now there is a technology called microinverters, and they're becoming more common, where this box becomes a lot of little boxes on the back of solar panels. And when I talked about the standard string diagrams, we provide 4 templates for those. One of the templates that is provided is for installations with microinverters. So it's very easy for an installer to pick up that template and put the relevant information in, and then for the electrical inspector to pick up that diagram and then be able to interpret the installation and the plan and ask the appropriate questions for the installation. It may change some things in the electrical diagram, but we did provide for that. So that's a really good question. Another question here. For installer qualifications, if they are on the PA Sunshine approved list, do they have any other qualifications? Can they check more than one? Yes, they can. So I showed you in our example that we had a NABCEP certified installer who was also on the PA Sunshine approved list. And we do have installers in Pennsylvania that may have all of those qualifications, which is fantastic. But given what we know about the requirements for those different qualifications, those are all qualifications that you can rely on for vetting a qualified installer. So another question. The spec sheets that I showed you, those are from the manufacturer, and that's the question. Are they from the manufacturer? Yes. The spec sheets are coming with the components or downloadable on the manufacturer's service website. Let me just zoom in here. So this Sun Module spec sheet obviously comes from Sun Module, and once again you can see all the system integration parameters, types of materials, questions, answers to questions that are posed in the permit process, and then once again the technical data sheets for UniRack, another important part. Also serves as a clearinghouse for a great deal of information on the installation. And then finally, there are some spec sheets that are a little less fancy, but still, once again, answer all the questions that need to be answered. So this is a spec sheet for the inverters. So you can see a lot of data here on voltage tolerances and things of that nature, all provided by the manufacturer based on their testing. So one last question that I have. If somebody wants to install backup batteries, can this process handle that option? Well, the answer to that is no. So once again, this process handles a majority of the kind of systems that you will see. Battery backup systems are not a very common application for solar right now. And because of that, there's some electrical considerations, some additional electrical inspection that would need to be completed. So that does not cover this would not cover battery backup systems, but once again does cover the majority of the systems that you are likely to see in your municipality. So a lot of good questions there, and once again, these questions are being asked on the sidebar of your webinar control panel. So please ask more questions throughout the process as you'd like. So that was the overview of the permit process, and I'm gonna switch gears here back to some PowerPoints, and let's see here. Okay. So the permit fees. This is something that we do want to bring up. So, sorry, where are my permitting fees? Is it from the very beginning? Yep. Permitting fees. There we go. So what we see in Pennsylvania is a trend towards value-based fees for solar installations, and I'll get into a little bit about that. What we recommend is a flat fee for very practical reasons, and that flat fee would include zoning, permitting, and electrical inspection if possible. So let's talk about this. Pennsylvania, as far as permitting fees go, versus the national trend in permitting fees. So there was an assessment done of Pennsylvania that surveyed about 30 to 40 municipalities to determine where we were falling as far as fees go for solar installation. And you can see here the best practice nationally is a fee of about $250, and it's fixed and flat. But the Pennsylvania average is coming in significantly higher than that at about $450, and that's because it's mostly value-based. Now, what we do know about solar installations is that they do tend to be a little bit pricey. The equipment is expensive. And that doesn't stop a lot of people from getting them, and there's a very practical return on investment. But the upfront cost is expensive. But it doesn't take a lot of time to install a solar installation, about 2 days, 2 to 3 days, given the situation. Moreover, it does not take a lot of time to inspect a solar installation, given the process that we laid out. Unlike an addition to a home, which may require 3 or 4 building inspections throughout the process and takes months to build, but may actually cost about the same as a solar installation, you can then see the difference between a value-based proposition and a fixed flat fee. So that's really where Pennsylvania is bucking the national trend right now, and we'd like to open up that conversation wherever we can. Some municipalities have a value-based fee, but it's on a it's a stepped value-based. So even though they're value-based, it's because they're classifying solar as maybe a mechanical system, it's still coming in much less than $250, and that's fine. But treating it as the same value-based fee as you would in addition to a house does not make practical sense. So something to consider, especially if you're looking at adopting our model ordinance or model permit, perhaps a model inspection procedure, or perhaps a flat fee permit could go with that. So some resources here that I just wanted to touch on. You received an email before this webinar that did have links to our model permitting procedure that was developed through this Sunshot process, or through the Solar Rooftop Challenge, our model zoning ordinance, and the Solar Guide for Municipalities, which is a guidebook that goes into great detail on the underpinnings and technical considerations for both of these models. And those are available at our website, which is www.pennfuture.org/sunshot. You can see that now, and you can see right here there is a place to download those. So if you haven't already received those and you want to share, you can go ahead and do that. Let's see here. Another resource that you were sent today was a link to this, the Photovoltaic online training for code officials, or PVOT as it's called. So you do have a live link to this. This is an online training module for that's geared towards code officials, so electrical inspectors and other code officials. You can get continuing ed credits through the state of Pennsylvania through IAEI, and that's who's sponsoring this training. So it's an International Association of Electrical Inspectors training module. You can go through it at your own pace. It's 7 lessons. I believe they take about an hour each. And if you do need continuing education credits, it's something that you can take advantage of. It is a three-dimensional sort of training module, so you actually use these sort of images to do virtual tours of different solar installations. So it's a resource that can be shared with other municipal officials and throughout your own municipality. Suggest taking advantage of it if you can. And once again, you received a link to that in the email. So, well, finally, so we did a lot of work in the last year on designing a model zoning ordinance, this model permit, and some other practical considerations for solar. And we did that in western Pennsylvania with about 24 other municipalities, as Sharon had stated before. But we have an opportunity now to take this work statewide. So we are looking for more municipal partners in this process. So if you're attending today from a municipality that's not familiar with our work, but this sounds interesting, please visit that website that I showed you before. It has all the details on participating. For a municipality to participate, they have to commit to 60 hours of cost share over about a 2 to 2.5 year period. So that's cost share in time. So time with municipal officials to spend on webinars, go to meetings, review different models, give feedback. That's what's involved. And this last round with our 24 municipalities likewise had a cost share component. So you commit to the 60 hours of cost share through a letter of commitment, which we actually need by March 1st. And yes, that is less than a month away, but it's essential to including your municipality in this grant to second opportunity. And what your municipality would receive is so free consultation by professional planners. So that was something that our municipalities enjoyed. Our professional planner was environmental planning design out of Pittsburgh. Reimbursement for solicitor review. So if you're going to institute the solar ordinance, then your solicitor would have to review it. We provide up to $500 of reimbursement for that review, but also public meeting advertising. So if you're going to pass a new ordinance, obviously you have to advertise a public meeting. We provide for reimbursement for that. Free registration for electrical inspector training and other inspector trainings for solar systems in your region. So we did a free training for this last session. We had over 70 inspectors and other municipal officials in attendance. That would obviously be free to you for participating in this grant. Free registration for municipal staff for those installations. Presentations by Penn Future staff with elected officials and planning commissioners, and then at the very end, a Sunshine Community Certification. All in all, there's quite a bit of value to this participating in this process. But overall, the value is getting ahead of the game. If you haven't seen a lot of solar installations in your community, you will. So taking the steps for and guiding your community through a process that allows them to become solar ready for a period of time where they will see upwards of 10 or 20 of these a year or even more. As the price comes down, we continue to see more growth. So getting solar ready now is certainly in your best interest. And here's an opportunity to take advantage of some federal resources from the Department of Energy and some experience from folks that have been working on this kind of topic, from Penn Future, from EPD, and from all our partners out there. So if you do want to participate, once again, you can go to this website, which is pennfuture.org/sunshot, and you will get a whole rundown of what's involved. There is a model letter of commitment there for you. There is access to all our resources and some answers to some questions. So I will open it back up to questions from the group. Once again, we do have some time for some questions. If you have questions about anything you heard today, please feel free to type those in, I know you're still out there. And you can, of course, yeah, you can, of course, email us any questions. Once again, at that website, there is an email address that can be forwarded. You can forward any questions that you may have. I got one that says great info, no questions. Thank you. Oh, here we go. How would this process work with the backyard installer? So I think what this individual is referring to is the backyard installer, somebody who would take it upon themselves to just install a system. If I'm not correct in interpreting that question, please go ahead and try again. But so there are some folks out there that take it upon themselves to buy different components of a solar installation and then try to install it themselves. This permit process would not apply to them unless they met the requirements, the pre-existing, the qualifications as outlined in the permit. So a sort of weekend warrior, that maybe does work around his house. This permit process would not be designed for them. Moreover, there are some very practical safety considerations. You're putting electrical components into a home and wiring those electrical components into your existing breaker box. So there's some very practical safety concerns that we'd be concerned with an unqualified individual installing solar. Moreover, our process outlines that an electrical inspection would be the last step in that because of all the electrical considerations. So our process does not cover that. Okay. Aha. Okay, so here's a question. There is an existing solar installation in our borough. It's very small, one panel. The fees you suggest would make the small installation not going into the grid cost prohibitive. Okay, so a one panel small installation is probably serving some sort of service to something existing on the building. I can't really guess, but the $250 fee that we recommended would be the ceiling, obviously. So we'd recommend $250 or less. You can certainly assess installation on a per installation basis, but a flat fee of $250 that would cover the inspection, the permitting, and the zoning is what we're recommending. Of course, that can be less. And here just to clarify that one panel system is providing power for an outside and inside light. So it's more akin to a solar panel that's charging likely a battery than the lights are tapping into that battery. So it's unlikely to be a grid tied system. And what we discussed today was systems that are grid tied only. Yeah, for a small one panel battery system that's supplying a light or some landscaping lighting, yeah, that if you have a procedure to that somebody would need a permit for that. This is really talking about grid-tied, net-metered residential systems. Would not pertain to that. But if you do have a permit fee, you can certainly entertain lower permit fees for different situations. Okay. Let's see here. Other questions? Okay. Hearing none. Once again, you can contact us with other questions as they come up. at our website there is a an email address, sunshot@penfuture.org. I didn't post our specific email addresses, but this is a really good catch-all. Likewise, if you have any questions about participating in the second grant application, please don't hesitate to call us. There's a hotline number here, or leave us an email, and we will certainly answer your questions in a timely fashion. And please you share our model permit with the appropriate officials in your municipality. Ask questions as they come up. And we thank everyone who attended this webinar today. The webinar is being recorded and will likely be posted on our website as time permits. And thank you again for participation. Thank you to Sherry Shapiro for joining us from Philadelphia. Thank you to Sharon Pillar for giving us a nice primer on the great work that she's led us as project manager here on Sunshot 1, the first solar rooftop challenge. So I'm rambling now, and I will say goodbye. Thank you. All right.